This is the schematic for my system, or you're going to see me build this here. The Centaur is feeding a set of bus bars that are Victron bus bars that connect a large array of lead acid batteries. Is 800 amp hours worth. Half of this battery array is a VRLA. That's two 200 amp hour batteries parallel. In the other half, which is four 100 amp hour batteries, are just SLA gel style. These are all Renogy lead acid batteries. I haven't noticed any difference between the two different kinds of batteries, and it's possible to just parallel them all together and it works just fine. At least that's what I've noticed. I mean, the errors in the voltage offsets in the Renogy chargers are larger than the small differences in the battery styles anyway. Now I've received a Victron battery charger in the mail, so I'm gonna open it now. I have not checked out. This is gonna be my little unboxing video here. This knife was given to me by my uncle when I was a little boy, and I kept it for years, kind of just forgetting about it. I always imagined that I'd use it to, like, in the apocalypse somehow, because it looks kind of apocalyptic. And how that translates into the real world is I'm now using it to open box for a battery charger. Protect myself from power outs during smoke outs. So it is essentially being used for the apocalypse in apocalyptic fashion. So that's this one here. It's a nice leather sheath on it. So, in the picture, in the video, in the eBay picture, this thing looked all kind of dingy and kind of off-colored. So I was afraid that it was going to be somehow damaged and badly worn looking or something. But I didn't pay that much for it, so I was willing to take the risk. But it turns out it's pretty much, except for the scuff, which was shown in the pictures, it looks like it's in perfect condition. The blue is not tarnished, and it looked light blue in the photos on eBay. So it's not anything, it's not bad looking like it was in the photo. So maybe I got a good deal if it works. Just so you know, a Centaur battery charger is pretty basic. All it does is it's just a glorified battery charger. It's can do up to 60 amps per channel on 3 channels. At 60 amps total, I don't think it can do 60 amps simultaneously on 3 channels. It just doesn't have the wire thickness for it. It's missing the mounting clip. I was expecting it to have a mounting bracket, but appears that that's missing. So I'll have to do something about that. They didn't mention that it was missing that. Well, I may have to be creative about that. And I think I can charge a lithium-ion battery with it using a Victron DC to DC converter, and see if I can boost it up from 14.4 to 16.2 volts. And then the battery's internal BMS will prevent it from overcharging or unbalancing. So hopefully this will work with lithium-ion batteries. But for now, I'm just going to use this to charge some lead acid batteries. In the long term, I'm going to have lithium-ion batteries as my cycling batteries and an array of lead acid batteries as standby to take over in case the lithium ions get drained. But for now, I'm actually cycling the lead acids. Okay, I'm now going to work on my Apocalypse Prepper solar system. My batteries don't get recharged enough when the sun is low, so I'm going to add a Victron charger to it, to the lead acid parts. Those will eventually become standby, and I'll be cycling only off lithium batteries. But for now, half my system cycles off lead acid and half it cycles off lithium. So I'm going to augment the charging with this Centaur charger. So when it's dark or stormy, but the power is not cut, I can top them off. This helps a lot because that means my failure modes are reduced to, it has to be stormy and dark for 2 days in a row, and the power has to be permanently out in order for me to lose power, which is a pretty good level of redundancy. Plus, I also have to be out of gasoline and propane because I've got generators that can recharge my batteries from those. So only if all those things happen, I'll lose power. Otherwise, which might only happen like once a year or once every 2 years. So possibly this might run pretty much until propane is out. So I got this Siemens disconnect. I'm actually going to repurpose this. So this is going to just go to the wall, and a part of it is going to just go into the Centaur as the power in. This can handle anything from 240 volts AC to 120 volts AC and even DC power, but I'm only going to use it for 120 AC in, 60 amps DC out, 12 volts to charge my batteries. I happen to want this connector, so I'm going to remove it from this Renogy inverter that I have laying around that I'm not using. So I'm going to disconnect this, and I'm going to use this on the output of the Centaur so I can disconnect from the batteries. The main tools I'm going to use are a hydraulic jack, wire strippers, screwdriver, and a insulation slitter for the cables, for the thick power cables. And hydraulic crimp jack looks like that. The hydraulic crimper looks like that. I used to mess around with a hammer crimper, and I decided to not bother, and I'll only use hydraulic now. Okay, so I removed the cable, and this one is nice. It's got 2 lugs, and it's also going into this connector. I may actually end up using this to go into my links distributor, which I will show you here, instead of cutting it. I've got this links distributor that goes to my batteries, and so I may actually use that cable to go to the links distributor, and I may rescue that old connector and use that as the output from the Centaur. So I've removed this from the wall. These cables are so short and they're not even heat shrunk. I'm probably gonna end up trashing them, but I'll keep them around just in case, because you never know when you need such a thing these days. And, to remove them, I can just push down on the pin here and it should pull out. It's actually slightly trickier than I remember because you have to push down on this thing here. I mean, it's made to not really come apart easily. So you kind of almost need 2 screwdrivers, one to kind of depress this metal flange and the other one to push the connector out at the same time. So it may take a little bit of practice to do it, but it can be done. Okay, so I got these out, and I've got an empty shell. Now it's actually hard to get the pins for these things. So I've got some extra pins. These are actually kind of heavy gauge cables, but these are compatible with the these shells. These pins are like $8 each. I've now opened the Centaur. You can see there's DC plus, DC plus, DC plus, DC minus, and a power in. So the power in will just get a standard power cable, and I will probably use this one. And the DC plus and DC minus is common to 3 different circuits, 3 different battery arrays that this can charge simultaneously. But I'm only going to charge 1 large array with it. And I can put any cables I want here. This is too short, so I'll have to make a longer cable to go from here to these.
and then I will then go into the shell. This shell will then mate with this other shell, and this will charge my 12-volt battery banks by plugging into the Lynx distributor or the power in. I've now connected two fairly heavy gauge cables. I think these are 4 gauge maybe. These are 4, yeah, these are 4 gauge cables. And I've connected them here, each one to one of the 2 terminals inside. These will now go to these crimp pins to the Anderson 175 amp connector. I have now crimped the first of these, but I'm going to now also put some heat shrink on there, and then I'll crimp the other one. My heat shrink was too small, so I shifted to a larger size. And one of my small pieces I'm going to move over here because that wasn't heat shrunk before. And then I'm going to finish these soon and insert them in the connector. I'm going to use this high power heat gun to apply these heat shrinks to these 2 connectors. And then they should be good for long term. I'm now going to insert these, make sure I insert the right one into the right one, although I can just move them around if I need to. My minus, this is my minus. I'm going to find the one that's labeled minus on the connector. That's this one. So this one must go into here. And the other one, by process of elimination, doesn't require much brains, goes into there. There we go. The connector is ready, and it's got longer wire pigtails so that it can feed the Centaur properly and go to the battery charge cable. This one will go to the battery array. And these cables can easily handle the 60 amp max current, and the connector is good to 175 amps. So these should be able to handle the Centaur at full power. Okay, so now I've wired it. This is a used eBay unit, so I'll have to check to see if the smoke comes out when I turn it on. But yeah, power cable's plugged in here. It's missing a piece for the strain relief, so I'll have to fix that later. And I've got my lines here, and then I'm ready to set it up soon. Okay, I've set up a temporary workaround for the missing strain relief piece with cable ties. It's not going anywhere. I've now connected it, plugged it into the wall, and the Anderson connector is here feeding my battery array. These are all lead acid batteries. It's about 800 amp hours of batteries, some 200 amp hour and some 100 amp hour batteries all in parallel, connected together through that Lynx power in. I'm connecting the Centaur directly to the bus where the batteries are connected, but this is just for test purposes. Later I will move them over to the one on the right where the solar chargers and the output is connected. It doesn't actually matter, it's all just one big bus bar because I don't have a shunt and a measurement device in the middle. But that's just, again, initially just to get this thing running. This here is my solar system and the Victron energy unit charged or plugged in, and you'll notice that it is currently not charging my batteries. It's 0 amps, and the batteries are fully charged. You'll notice that the 2 rover Renogy's are actually connected to the same batteries, but they read slightly different because the Renogy's are just absolutely terrible with their voltage displays. So it's displaying 14.4 and 14.6, but they're actually at the exact same voltage, and they are in fact tied to this Lynx power in, which I'm using as a distributor, and all the batteries are shorted together and tied in this Lynx power in. Well, they're parallel together in this Lynx power in. So these two bus bars, there's no voltage gradient there. These are reading the same voltage, yet they're reading significantly different voltages. And that's because of it's just the Renogy voltage display, possibly their voltage sense circuit is terrible. Now, so when you program them, you have to custom program them and adjust the voltages slightly to compensate for that. And that's kind of the biggest drawback, other than the fact that they're really easy to set up. This is a description of the schematic. Basically, I've got the Centaur getting fed by the utility, charging all of these batteries in parallel. It's like 800 amp hours of lead acid batteries here. This goes to the other power in, which I'm using as a distributor. The MPPTs, 2 of them are tied to it. This other MPPT actually goes to a lithium ion system, and that feeds the inverter. The inverter goes to a Spartan automatic transfer switch, takes utility and load, which runs a bunch of freezers and also refrigerators, as well as I can run the laundry machines from that. So there's the Spartan automatic transfer switch, currently running off batteries. I'm using the sense lines to read the output from this Renogy, and I can turn it off and on from the load on the Renogy. So I'm using the load off the Renogy as the voltage input sense on the Spartan. It's not running anything else. So that's like, I find the Renogy output load as useful in that way. I do not see it as useful for running any real loads. It's more of a just running the voltage sense circuits, because that basically is the output of the battery. And so now you'll see here reading 14.5 volts, whereas here it's saying 14.4, 14.3, and there it's saying 14.6 volts. I have noticed that these Spartans tend to be pretty accurate with their voltage readouts, so it's really 14.5. So this one's 0.2 or 0.1 or 0.2 low, and that one's like 0.1 high. You have to be careful when you program your Renogys, especially if you're using lithium-ion batteries, that you have to figure out what their actual micro offsets are, which could be 0.2 volts or more, so you don't overload or overcharge your batteries. I'm now working on my power switch. This one, I'm going to plug this into the wall, and then I can disable or enable the Victron charger manually. Also, I can put this into a timer, so I can, for example, only use the Victron and line power to charge the batteries if the sun didn't charge it enough during the day, by just setting the timer to start charging at midnight and then turning off at 6 a.m. Okay, here we have it. We're done. This is the master power switch. This is not a solar DC disconnect. That's an old label. Let's see, actually, the utility mains disconnect. So basically, if I do this, it shuts off the Victron. However, the Victron has a lot of energy in its transformer coil, so it takes a long time to shut off. Now it's shut off. That charges through the power in, it charges the batteries. Later on in the future, I'm going to move it over to the second power in, because I'm having the batteries connect to this one. I'm having all the MPPT chargers and the Victron charge the batteries by going through here. This also feeds the inverter, so that's like the interface box, whereas the first unit is the battery box. So the interface box, the interface power in, this one is for batteries and this one is for chargers and loads. And now I'm going to throw the power on. And you can see here, this will jump up. However, the batteries are fully charged, so they won't draw any power. And the idea is I could literally just put this on a timer, like this one, just stick it up there, and have it only charge at midnight to 6 a.m. That way I know it's not going to charge at the same time as the solar, or I could just leave it and manually switch it on and off if I want to. That was a load. You could see that there was a brief burst of power, and that's because a refrigerator must have turned on and drew some load and made it favorable to charge. So that's it. That's the full system. This 2 kilowatt inverter is actually the backup power for a 1 kilowatt inverter somewhere else with a automatic transfer switch based on power failure on the 1 kilowatt inverter. So this 2 kilowatt inverter runs a couple freezers and refrigerators, as well as the washer and dryer, and also serves as the backup source for a different one. So I basically have everything running off a kind of a multiply redundant solar battery system.